In 1989, Drs. Pons and Fleischmann, two scientists in Utah, shocked the world with their announcement that fusion reactions could be achieved at low temperatures. Since then, hundreds of scientific organizations around the globe have quietly continued their quest to harness this potentially unlimited energy source.
The sun's fusion reaction is the ultimate source of all life-sustaining energy on Earth. Even the energy contained in the fossil fuels we use today is the energy of the sun captured by plants and animals millions of years ago and then released when we burn these fuels in our power plants and vehicles. These energy sources are inefficient, expensive, and most important, limited and non-renewable. Science has been looking for a solution to this energy problem for years. Clean Energy Technologies Incorporated has the solution today. Clean Energy Technologies, or CETI, based in Texas, is a private corporation formed to be the exclusive licensing agent for the technology developed by Dr. James Patterson. Dr. Patterson has invented an energy system that will solve the problems of dwindling energy reserves and satisfy the growing energy demands of today's economies without destroying the environment. It will entirely change the current methods of energy production and utilization. A safe, reliable, and efficient way to harness the energy of the sun using the most abundant resource we have on Earth, water. Dr. Patterson has discovered that the excess heat generated by the interaction of water, palladium, and platinum can be efficiently captured and harnessed. This discovery is so profound that conventional science is now trying to understand its theoretical and practical implications. The technology is covered by CETI's 4 patents. These are the first patents of this kind to be issued anywhere in the world. This new hydrogen energy is more commonly known as cold fusion. Clean Energy Technologies is proud and excited to present the fascinating story of the Patterson Power Cell and the reality of a clean, abundant, efficient, economical 21st century power source that is under development today. A source not based upon the burning of fossil fuels nor the splitting of atoms. Hydrogen that is found in every molecule of water is used to stimulate an excess heat reaction that generates a tremendous amount of energy. That heat, then, is transformed directly into other forms of energy. At the same time, hydrogen and oxygen gas is created as a byproduct. CETI was formed with the prime objective of making this exciting new discovery a commercially viable energy alternative. Dr. Patterson originally developed much of this new technology in the early 60s and 70s while working on the amino acid analyzer, which is the foundation of all of today's DNA analysis. He is now CETI's chief scientist. This is a diagram of the system for the electrolysis of water developed by Dr. James Patterson. This system is unique in that it is a closed-loop continuous circulation system that uses either light or heavy water as the flowing electrolyte. The electrolyte flows through the entire system and comes in direct contact with the electrode, allowing high current densities and high energy fluxes within the cell. The design of the system allows inline or online diagnostic testing without removing the cell from a production array. There are obvious cost benefits to this system. It utilizes light or ordinary water as the electrolyte and minute amounts of precious materials in the electrodes. The flow design is superior from an engineering standpoint, signifying a promising scale-up for commercial purposes. The electrolyte is drawn into the circulation system from a cooled feed reservoir by means of a constant volume, stroke rate controlled pump. The medium, or water, is transferred by high-pressure Teflon tubing using stainless steel connectors. The pressure of the system is continuously monitored by a pressure gauge connected in line. The medium then flows through a stainless steel filter containing a cellulose acetate screen. This removes any colloidal materials in the medium and allows the composition of the electrolyte to be monitored at all times. The Patterson Power Cell shown here has already been scaled up to 4 times its original experimental size. With each scale-up, we have seen significant increases in the relative heat that is being generated, as well as other operating characteristics. The research cell is composed of non-conducting industrial-strength glass that is 1.9 centimeters in diameter and 6 centimeters in total length. The heat-producing reaction takes place inside the microsphere bed, which is less than 2 centimeters in length. This small area produces extremely high energy densities. Notice that the design allows for compression at both ends of the cell. This is done in order to get uniform microsphere bed packing in the cell, which is a vital step in the production of excess heat. O-rings are fitted around these movable non-conductive ends, which are compressed by means of plates and screws on the outside of the cell. Temperatures are measured at both ends of the cell by glass-encased J-type thermocouples that are in direct contact with the flowing medium. Contacts are mounted on platinum screens forming the cathode and the anode. The contacts extend from inside the cell and are connected to a constant current power supply having both positive and negative terminals. Input and output temperature, current, and voltage are carefully measured and recorded on a multi-point strip chart recorder. A backup measurement of current and voltage is also recorded. The electrolyte is composed of light water and 1 to 2 molar lithium sulfate, depending on cell resistivity. The medium enters the cell and then directly contacts the coated microspheres, producing an excess heat reaction. Heated water then exits above the cell. The circulation of the electrolyte through the cell allows for high current densities and energy fluxes within the cell with no complications. The cell design allows for increased conductivity of the electrolyte after hydrogen loading. A significant benefit of the system is that the flowing electrolyte can be used as the heat-to-energy transfer mechanism. The coated microspheres are the highly specialized catalysts for the excess heat-producing reaction. Clean Energy Technologies has focused a large portion of its research on the development of these microspheres and now has 2 patents that specifically cover their use, design, and the substitution of other materials. Using a complex plating process, various metals can be substituted or combined to produce effective results. This diagram illustrates the nickel-palladium-nickel configuration, which is effective in our light water system. This is the microsphere before the plating process begins. The base of the microsphere is composed of cross-linked styrene divinyl benzene, a stable cross-linked copolymer that can withstand extremely high temperatures. In this example, copper chloride is added to form a strong bond with the polystyrene substrate by exchanging hydrogen ions with the copper metal salts. This creates a microsphere with a thin copper flash coating that performs uniform catalytic functions without creating hotspots that would otherwise blow the metal coatings off. Various metal coatings are now applied to the conductive microspheres. A nickel coating of micron size is added by means of an electroplating electrolysis process. Then a micron size layer of palladium is added by either the electroplating or the electrolysis process. Finally, an outer layer of nickel is added by the electrolysis process. This microsphere design allows for extremely short charging times at low current. The normal charging time is approximately 4 hours at 0.05 amps for this microsphere configuration. Because of the geometry and the use of many microspheres in the form of a bed, a large surface area is created upon which the reaction takes place. The microspheres utilize less than 1% of the amount of palladium used in other electrolytic cells of comparable size. Another property of the coated bead is its ability to withstand both compression and expansion forces of over 30,000 atmospheres of pressure during the heat production process, allowing it to maintain its structural integrity. In addition, as pressure is applied to the beads in the system, their sublimation temperature rises significantly higher than 250 degrees Celsius. This is the temperature at which the beads change from a solid to a gas at 14.7 pounds per square inch. This fault-tolerant system allows for several microspheres to fail without significantly affecting the cell's heat production. Also, there is a natural fail-safe characteristic built into the system that will shut it down if temperatures rise above specific levels. After the medium leaves the cell, it passes through a liquid-gas splitter. This device enables the flow of hydrogen and oxygen to be measured independently of the liquid flow. These results are monitored by a gas flow meter. The liquid flow rate is measured in the laboratory by means of a graduated cylinder and a stopwatch. The medium is then returned to the feed reservoir without changes to its composition. At this point, the medium is very hot. Prior to re-entering the system, the temperature of the medium is reduced to its original level by a cooling unit at the feed reservoir. In a practical device, the heat or steam produced would be converted directly into other forms of energy. The engineering benefits of the flow system, the capacity to produce enough excess heat to generate steam, the limited use of raw materials, and the positive environmental impact of creating energy with ordinary water will ultimately dictate that this system, or one very similar to it, will be an economic necessity in the future. The results that CETI has achieved have been very impressive. The Patterson Power Cell, using light water, repeatedly produces excess heat yields of over 1,000% at low currents and 250% and above at high currents. That is to say, for every 1 watt that is put into the system, at least 2½ watts are recorded exiting the cell. These results are 100% reproducible. In addition, there have been many individual runs that have significantly exceeded 500% at the higher currents. Here we see the gases and the liquid as they exit the cell. The medium is actually turned into steam due to the high temperatures that are created. Over the past several months, CETI has worked with several individuals and institutions that have independently verified these results. CETI has focused its aggressive research on a system that can be economically scaled up to commercial power levels. CETI is scaling up the size and efficiency of the cell and expects to produce 1 kilowatt of power as part of a larger 250 kilowatt power array. To achieve a more rapid advancement of this technology, CETI is selling research and development licenses for specific applications. Cells and beads will be available to those who have serious interest in purchasing research and development licenses. CETI is also actively seeking strategic partners to join us in the development and commercialization of this exciting new technology. The ramifications of this discovery are profound. It will have a direct impact on every individual, home, industry, and every mode of transportation. CETI invites you to join us in our journey as we move toward the fulfillment of the human quest for a clean, unlimited, economical energy source.